Hello students, how are you all? Myself Swapnil sir and welcome to you all on our complete lecture series on JEE MHT-CET previous year question paper. Already we have uploaded plenty of the videos on our channel based on the syllabus of JEE and CET. So if you are interested to see this video, do check in my playlist. You will get all these videos there. So in my today's video, I'm gonna explain to you all some of the previous year question from JEE and CET, and all these questions I have taken from latest previous year question paper. So first of all, I'm going to explain to you all some of the basic concept, and then at the end we go for some of the important previous year question paper from board JEE and CET exam. Now without further ado, let's get dive into our today's lecture. We'll go for some of the basic concept first, and then at the end we go for previous year question paper. Okay, now here in our today's lecture, first of all, today's lecture, it is completely based on the differentiation, and it's a sub part of the differentiation. Okay, so we are going to understand all these concept detail. First of all, let me explain to you all what is meant by differentiation. Okay, the differentiation means the rate of a change of a quantity. Okay, rate of a change in any quantity, we denote it as the differentiation. Okay, so some mathematical formula for differentiation, it says that when we have differentiation of any function, as we consider it as the limit as h tends to 0, f of x plus h minus f of x upon h. Okay, so this one is the differentiation of any function. We define it as the f dash of x. Okay, this one is the f dash of x for finding the differentiation of a function. Okay, so by using this formula, we find out the differentiation for function. Now what happen in most of the case, we cannot apply same formula always, because there are some of the difficult type of the formulas that their proof are time taking. Okay, so we don't have time to go for the directly formula and then substitution of the value. It is time taking. Okay, now instead of this, we have to remember some of the standard result, like a differentiation of x raised to n as a nx raised to n minus 1, that we don't have to find out their differentiation by using first principle of differentiation. Okay, so in this case, we directly apply some of the rules. Okay, now after this first principle, we're going to understand the composite type of the differentiation. How can we differentiate the function? Okay, so if I consider y which is equal to f of x, okay, y which is equal to f of x as the function, okay, and I want the differentiation of this function. So what we do first here, we take the differentiation of a function first of all with respect to x. So dy by dx, differentiation of y, it goes to the dy by dx. Similarly, differentiation of f of x, okay, that means d by dx of f of x. Okay, and the function under function that we differentiate that x later on, dx by dx. Okay, this one we call it as the differentiation of a function by using composite rule. Okay, that means we have to differentiate that function with respect to some another variable, and that variable need to differentiate with some another variable. Okay, that we consider as a x variable or a y variable. Okay, so composite type of the differentiation we are going to apply everywhere in our upcoming examples. So for that, let me explain first of all to you all types of the differentiation. Okay, the basically we are going to study 4 to 5 standard types, like a logarithmic differentiation. After that, parametric type of differentiation, implicit type of the differentiation. This type of the differentiation we are going to understand in a subsequent part of our example. Okay, so first, logarithmic type of the differentiation. Okay, logarithmic type of differentiation. Logarithmic type of the differentiation. Okay, so logarithmic, what is the basically meaning of a logarithmic type of differentiation? Okay, when we are going to find out the differentiation, we come across some difficult type of the examples, like a function to the power function, function divided by function, function multiplied by function. Okay, so these type of the results are quite bit difficult. These types of the examples are quite bit difficult for finding their differentiation. Okay, so in such a case, we apply some of the rules from the logarithm chapter. Okay, we apply some of the rules from the logarithm chapter to simplify our given function. Okay, and then subsequent part, you just need to apply the differentiation there. Okay, So only we are going to apply some of the rules from the logarithm chapter. Under differentiation, we consider it as the logarithmic differentiation. Now, for example, if I have function to the power function, then it is applicable rule is there as a exponent rule for the logarithm. So what is the exponent rule for logarithm? It says that when we have y which is equal to a to the power x, then the exponent rule of exponent rule for log, it says that first of all apply the log to both sides, log of a to the power x. Now see that log y which is equal to log of a to the power x is there. Okay, apply exponent rule for the differentiation. So what exponent rule? It says that whatever the power we have, we take it as the multiplicand for our given function. Okay, so log y, it remains as it is, x into log of a. Okay, see that this one is our exponent rule for logarithm that we use to simplify our given function, and at the end directly we have to apply the different rules from the differentiation. Okay, some of the standard formula we have to apply here for finding the differentiation. Okay, so that's it for logarithm. There are some another quotient rule, product rule, it is also there for the logarithm. Okay, then exponent already we have seen. Okay, these are the rule commonly we are going to apply here in our logarithmic differentiation. Okay, so next part of the differentiation, we consider here parametric type of the differentiation. Okay, parametric type of the differentiation. Let me explain parametric type of differentiation. So what is the parametric type of the differentiation? It says that till the moment we have learned differentiation of a function with respect to x, differentiation of a function with respect to y. Okay, so this one is the differentiation we learn here till now. But the parametric differentiation, it says that when we have to differentiate one function with respect to another function. Okay, like a differentiate f of x with respect to g of x, differentiation of one function with respect to when it comes another function, then we apply the parametric differentiation. Okay, now see that if I consider any function y and x. Okay, y and x, consider y which is equal to tan theta, x which is equal to tan theta. Okay, so I have these two function x and y here. Okay, tan theta and cot theta. Consider it as the cot theta, maybe consider both of them different. I am explaining here what the parametric type of the differentiation it says. Okay, so x I consider here cot theta, and y it is there as a tan theta. Okay, so I have to differentiate function x with respect to y, that means tan theta with respect to cot theta. Okay, and then we have to find out the value for dy by dx. Okay, yes, but as we have function x is in the form of theta, y is in the form of theta, then what we do, we differentiate y with respect to theta first, x with respect to theta second, and then we take their reciprocal. Okay, so we write it as the dy by d theta completely divided by dx by d theta. Okay, so dy by d theta upon dx by d theta, which is a parametric differentiation for our function. Okay, so this one is the parametric. Then after that, implicit type of the differentiation, and there are some other topics there. So we are going to understand these topics when examples are coming. Okay, so we'll understand this topic with some of the example. So without further ado, let's get dive into our today's lecture. Okay, with some of the previous year question paper. Okay, now here in my first example, I consider here function as a x which is equal to e to the power x divided by y. Okay, what we have function x which is equal to e to the power x divided by y. Okay, this one is our function given. Okay, and we want the value for dy by dx. We want the value for dy by dx. Okay, so this one we want here dy by dx, and function is in the form of x which is equal to e to the power x by y. Okay, so if we observe our given function carefully, it seems like that function to the power function it is given. Okay, like e to the power x by y given, that means function to the power function given here. Okay, and when we have function to the power function, always we apply logarithmic type of the differentiation. Okay, So what is the logarithmic type of differentiation? It says that when we have function to the power function, then we apply exponent rule. Okay, then we apply exponent rule for finding their differentiation. Okay, now apply logarithmic differentiation. Okay, logarithmic differentiation, we have to find out the solution using logarithmic differentiation here. Okay, now what do we do in a logarithmic differentiation? First of all, we are going to apply log to the both side to our function. So our function, we have here x, which is equal to e to the power x divided by y. Okay, as we have power as we have here function to the power function, so apply log to the both side. Okay, so we get a log of x, which is equal to log of e to the power x divided by y here. Okay, log of x, which is equal to log of e to the power x divided by y. Okay, apply rule of exponent rule from the logarithm. So xy by y, which is a part of a exponent here, so it goes to the multiplicand for our function. Okay, so log of x can be written as x divided by y into log of e here. Okay, log of x, which is equal to x divided by y into log of e. Okay, and a log e, we know that when log e, it comes together, so we mean that it is having base e. Okay, log to the base e of e, and which always gives us the value 1. Okay, or you may take when logarithmic term comes closer to the exponential term, it gives us the value 1. Okay, that means log e always gives us the value 1 here. So what is the next step? It is coming log of x, which is equal to x divided by y here. Okay, log x, which is equal to x divided by y into log e, means which is equal to 1. Okay, so y, it is a denominator here, take it to the other side. So y into log of x into, which is equal to y into log of x, which is equal to x here. Okay, this one is our function. Now see that this one is a simplified form of our given function. Okay, simplified form of a given function, I written this way, and go for directly differentiating our function. Okay, so differentiating means we have first function multiplied by second function, first multiplied by second function. That means we have to apply by part rule for differentiation. Okay, what is the by part rule for differentiation? It says by part rule, when we have multiplication of a function, first function into second function, that means d by dx of first function into second function. Okay, so we have to differentiate u into v. So what we do here, we take first function as it is differentiation of second function plus second function as it is differentiation of first function as the by part rule for our differentiation. Okay, when these two functions are coming as the part of multiplication. Okay, now see that first function into second function. Okay, so apply by part rule. First function as it is, y as it is, differentiation of a log x, d by dx of log x. Okay, first function as it is differentiation of a second plus second function log of x, keep as it is differentiation of first function. That means d by dx of first function is here y. Okay, and differentiation of x with respect to x, that means dx by dx here. Okay, dx by dx means differentiation of x with respect to x. So first function as it is differentiation of a log x with respect to x, which gives us 1 upon x. Okay, differentiation of a log of x, what is the standard form for differentiation of log x? Which is the 1 upon x. Okay, plus log of x as it is. Okay, as we have d by dx of a y and we want the dy by dx, so we always keeping dy by dx, this term as it is, into differentiation of x with respect to x always goes to 1. Okay, and what we want the value for dy by dx. So the remaining term from this side, take it to the other side. What we get here, log of x, which is equal to log of x into dy divided by dx. Okay, log of x into dy by dx, which is equal to minus y divided by x here. Okay, this one is our next step. So we want the dy by dx, take remaining term to the other side. Okay, so we get the next step as, okay, so we can see that here minus y upon x, okay, minus y upon x. So plus we have here y upon x, it goes to the minus y upon x, which is 1 here. So what we do here, that y upon x plus 1 it remain here. Okay, y upon x plus 1, this one here 1. Okay, take that log x to the other side. So before taking, multiply this one, so x into 1, so we write next step as a x into 1, x minus y divided by x. Okay, this one is the other side. So take log x to the other side, we get the dy by dx, which is equal to x minus y as it is, as the part of numerator, log x, which is a multiplicand here, take it to the other side, we get as the denominator, x into log x. Okay, dy by dx, which is equal to x minus y upon x into log of x here. This one is the our required differentiation from our example. Now see that which one of the option here, dy by dx, which is equal to x minus y upon x log x, which is the option number B, option B, which is correct here. Okay, now see that how easy type of the questions are coming in your CET JEE exams. Okay, now see that this question, which is from 2022 MHT-CET previous year question paper. Okay, so I hope you all have understood this solution. Let's move for the next question. Okay, yes, so I have taken the next question here as xy, which is equal to tan inverse of xy plus cot inverse of xy. Then we have to find out the dy by dx for some particular points. Okay, so we have to find out the dy by dx at a point 4, 2 here. Okay, so first of all, we have to find out the value for dy by dx, and 4, 2 means we have to substitute the value for x is a 4 and y is a 2. You will get the required answer. Okay, so our function, what we have given in our function, xy, which is equal to tan inverse of xy plus cot inverse of xy. Okay, this one is our required function, xy, which is equal to tan inverse of xy plus cot inverse of xy here. Okay, now see that, and we want the differentiation for this function. As we know that tan inverse of x or cot inverse of x, they are having some standard formulas for finding their differentiation. Like we know that tan inverse of x, d by dx of tan inverse of x can be written as 1 upon 1 plus x square. Okay, so we write tan inverse of x is 1 upon 1 plus x square. Okay, for finding their cot inverse, we do not take the reciprocal, because inverse trigonometric function are having sometimes a domain codomain different, because their values which coming from the domain, it restrict the value for codomain in some certain interval. Okay, that's why we do not take the reciprocal for inverse trigonometric function. Okay, that's why we have to find out the separate differentiation for cot inverse of x. So you may have to apply this formula, tan inverse of x is equal to 1 upon 1 plus x square, or one more result we know that when we have tan inverse of a theta plus cot inverse of a theta, we write it as the tan inverse of a theta plus cot inverse of a theta, we write this one as the pi by 2 here. Okay, tan inverse of a theta plus cot inverse of a theta, which is a pi by 2 here. Okay, so tan inverse of theta and cot inverse of a theta is a pi by 2. Apply that one here, as we can take theta as a xy. We can take theta as a xy here, theta as a xy here. Okay, that means tan inverse of a theta plus cot inverse of a theta as a pi by 2. So theta I consider here as a xy. Theta you may consider anything. Okay, anything what you want, but theta need to same here as well, same here. Okay, both theta need to be same. So both are same here. So tan inverse of x plus cot inverse of x can be written as pi by 2. So we can write next step as a xy, which is equal to pi by 2. This one is our simplified form of our given tan inverse of xy plus cot inverse of xy here. Okay. Yes. Now let's go for directly differentiating our xy, which is equal to pi by 2 with respect to x. Okay. So what we want here? We want the differentiation of y with respect to x. That means the dy by dx. Okay. For dy by dx, for finding the value for dy by dx, what we do? We differentiate directly this function. Okay. Directly this function, which is xy, which is equal to pi by 2. Okay. So as we have x into y, these are the two different function. Okay. dy by dx, which is a different function, and x, which is also different function. So consider first function as it is differentiation of second, plus second function as it is differentiation of first. Okay. That means first x function as it is differentiation of next function dy with respect to dx, plus second function as it is y dx by dx, differentiation of a first function, and d by d, which is equal to d by dx of pi by 2. Okay. And as a pi by 2, which is a completely constant term, and when constant terms are coming, their differentiation always goes to 0. Okay. So d by dx of a pi by 2 always goes to 0. Okay. That is a constant term, do not have any rate of change. Okay. So it goes to 0. So x into dy by dx, keep as it is, x into dy by dx, plus y into dx by dx, differentiation of x with respect to x, which gives us the value 1. And d by dx of a pi by 2, constant term, differentiation always 0. Okay. So dy by dx can be written as minus y divided by x. Okay. Because x, it is a multiplicand here, take as the part of denominator, but we want the value for dy by dx at a point 4 and 2. Okay. We want the value for dy by dx at a point 4 and 2. Okay. So what we want here? We want the value for dy by dx at the point 4 and 2. And when we get the order pair in mathematics, always remember, first element is goes to the x, and second element it goes to the term of y. Okay. So x, which is equal to 4 here, and y, which is equal to 2 here. Okay. X, which is equal to 4, and y, which is equal to 2, need to replace in a dy by dx. Now let's substitute dy by dx at point 4 and 2. That means minus y by x at a point 4 and 2. Okay. That means x is a 4, y is a 2. Substitute the value. Y is a 2 means minus of a 2 divided by x is a 4. So minus 1 by 2, which is a dy by dx. Okay. This one is the value for dy by dx, which is a minus 1 by 2. Now see that in our option number first, a, which is a minus 1 by 2, which is our required answer. Okay. So dy by dx, which is a minus 1 by 2, is our required answer. Okay. So this one is option number A, correct. I hope you all have understood this solution. Let's move for the next one. So in our next example, we have given function as a log of x plus y, function as a log of x plus y, plus log of, plus 3. Okay. So what is the function here? We have given function log of x plus y, which is equal to log of xy plus 3. Okay. This one is our given function, and then we want the value for dy by dx. Okay. This is the solution we want here, dy by dx here. Okay. Now in such a situation, you have log directly to the both side. You don't have to apply any logarithm term, implicit parametric type of the differentiation. Nothing is applicable. Directly go for the finding their differentiation. Log of x having differentiation 1 upon x. Okay. That means log of x plus y having differentiation 1 upon x plus y into differentiation of d by dx of x plus y function, which is a composite type of differentiation. Okay. Log of x having differentiation 1 upon x and d by dx of x plus y. So log of xy, again similarly, log x having differentiation 1 upon xy into d by dx of xy, okay, plus d by dx of 3. And as we know that a constant term gives differentiation 0, so keep it at 0 directly. So 1 upon x plus y into differentiation of x plus y, x having differentiation with respect to x, which is 1, differentiation of y with respect to x, we write it as the dy by dx, which is equal to 1 upon xy as it is, differentiation of xy with respect to x with respect to xy. These are the two different functions. Apply by part rule for the differentiation here. First function as it is, differentiation of a second, plus second function as it is, differentiation of first, which is 1 dx by dx, and plus constant differentiation, it goes to 0, okay. Multiply 1 upon x plus y under bracket. So 1 upon x plus y plus 1 upon x plus y dy by dx, which is equal to 1 upon xy, x multiplied by 1 upon xy, that means x divided by xy dy by dx plus y divided by xy, okay, and plus it goes to the 0 next step. Let me go for the next step here now. Yes, so 1 upon x plus y, 1 upon x plus y dy by dx, take the dy by dx at one side and remaining term to the other sides. So we have next step as 1 upon x plus y, okay, as the part here, dy by dx, okay, 1 upon x plus y dy by dx one side. Here next term x upon xy, x can be cancelled, so 1 upon y dy by dx, take it to the other side, so we write minus 1 upon y dy by dx, okay, minus 1 upon y dy by dx, and the remaining term take it to the other side, so y can be cancelled, so we write it as the 1 upon x, okay, 1 upon x as it is, the term positive here, take it to the other side, minus 1 upon x plus y here, okay, minus 1 upon x plus y. So let's go for the taking dy by dx common from here. So 1 upon x plus y, 1 upon x plus y minus 1 upon y into dy by dx, okay. So 1 upon x plus y minus 1 upon y dy by dx, which is equal to, go for the cross multiplication, x plus y here minus x divided by x into x plus y here, okay. This one is just a cross multiplication for two numbers, as we do in our rational calculations, okay. Yes, go for the cross multiplication here as well as y minus x minus y divided by x plus y, okay, into dy by dx. We write positive negative x can cancel, y divided by x upon x plus y, okay. See that this x plus y cancelled with this x plus y, okay, that negative y positive y cancelled here, okay. So we left here minus x into dy by dx, which is equal to y by y into x plus y is remaining, okay, minus x by y into dy by dx, y upon x here, okay. So what I have done, this cross multiplication for these two numbers and multiplication of a denominator here for these two identities, okay. So y into x plus y, and that positive negative cancel here, similarly that bracket cancel with this bracket, okay. So minus x upon y into dy by dx, which is equal to y upon x, okay. Take this term to the other side, so we write a dy by dx, which is equal to minus sign keep as it is, okay, y by x as it is here, this one is also coming y by x. So dy by dx can be written as minus sign as it is y into y square upon x into x square here, okay. So see that this one is our required answer, dy by dx, which is equal to minus of y square upon x square, which is our required option number C, okay, option C correct here. I hope you all have understood. It is only the simple differentiation for our given logarithmic function, okay. Question asked in March 20 MHT-CET 2022 previous year question, okay. I hope you all have understood. Let's move for the next example, okay. So in our next example, In our next example, we have given x which is equal to a into x which is equal to square root of a into sine inverse of t, and y which is equal to square root of a into cos inverse of t. And then we have to find out the dy by dx here. Okay,